Welcome to the deep dive. Today we're digging into the really big shifts in artificial intelligence.
That's right. We're pulling from the AI index reports, the 2022, 2024, and the just released 2025 one.
Our mission really is to cut through the noise and give you the crucial stuff, the most fascinating developments in AI research, ethics, the economy.
Policy, public opinion, all of it. There's just so much out there. It can be overwhelming, right?
Totally. So, consider this your focused update. We want to pull out the key trends and insights.
And these reports, they're pretty solid. Stanford HAI leads it, but lots of experts chip in, academia, industry.
Yeah, it's rigorously vetted global data, unbiased, which is important.
Definitely. So we're aiming to give you that clear overview of what really matters in AI right now.
Okay, let's jump in. One area that always gets attention is technical AI ethics.
Yeah.
Specifically bias in these big language models.
Right. And the reports highlight this. Well, this paradox. Models are getting way more capable.
But the bias seems to be scaling up right alongside that capability.
Yes, exactly. There's a specific data point from, I think, the 2022 report. A 280 billion parameter model in 2021, compared to a 2018 model, much smaller, 117 million parameters. The bigger one showed a 29% increase in elicited toxicity.
Wow, 29%. So bigger isn't always better from an ethics standpoint.
It seems not. As they get more powerful, the potential harm from their biases also grows. It's a serious challenge.
And researchers are trying to measure this, right? Tools like real toxicity prompts.
Yes, and the Perspective API. They're trying to quantify this toxicity.
But it's tricky because trying to detoxify these models can actually hurt their performance on other tasks.
That's the trade-off. You try to fix the bias, you might make the model less useful or accurate in other ways.
There's specific benchmarks, too, aren't there, for spotting different kinds of bias?
Yes, several. Like stereoset, Crow-S pairs. Those look at broader stereotypes. Then you have winner-gender, wino-bias, wino-MT, specifically for gender bias, even in translation.
And it's not just text models. Multimodal models, the ones dealing with images and text.
They pick up multimodal biases. The classic example is CLIP misclassifying images of Black people as non-human at double the rate of other races.
That's deeply concerning.
It is. On the upside, maybe, research on fairness and transparency is growing, like a 5-fold increase in publications at ethics conferences since 2014.
And industry is contributing more to that research now, too.
Yes, definitely seeing more industry involvement there. But it's a deep-rooted problem. Remember those studies on word embeddings?
Trained on historical text.
Exactly. Trained on like 100 years of data. They absorbed all the gender and racial biases present in that text. It's baked in.
Okay, so bias is a major ongoing issue. What about truthfulness? Are these models getting better at sticking to the facts?
Well, they're getting incredibly fluent. They can generate text that sounds completely convincing.
But it might be totally wrong.
Precisely. They're getting better at generating factually incorrect statements very fluently.
Huh, that's not ideal. Is there a benchmark for that, too?
Yes, Truthful QA. It's designed specifically to test this. There's an example with GPT-3.
What was it?
It confidently answered that smashing a mirror gives you 7 years of bad luck. Sounds plausible, culturally, but factually nonsense.
Right, so fluency doesn't equal truth, a critical distinction.
Absolutely. Okay, shall we shift gears to research and development trends?
Yeah, let's do that. What's the big picture in R&D?
Well, first off, just the sheer volume. AI publications are still climbing overall. It's a really active field.
And collaboration. I remember seeing something about the U.S. and China.
Ah, yes. That's a big one. Collaboration between U.S. and Chinese researchers on AI papers. It's increased 5 times since 2010.
5 times. Wow. Despite, geopolitical tensions.
Seems like the research world is still quite interconnected there. And interestingly, in 2021, the most collaborations involved educational institutions and nonprofits.
So academia is still a major hub for this cross-border work. What about where the publications are coming from generally?
In 2021, looking at AI journal publications, China was leading with about 31%.
Okay.
Then the EU and UK combined were around 19%, and the US at roughly 14%.
So China's significantly ahead in journal output, at least in that snapshot.
Yeah. But if you look at AI repository publications, like RC, North America has kept a lead since 2014.
Different types of publishing show different patterns.
Exactly. And East Asia and the Pacific region have shown huge growth in repository submissions since 2013 as well. It's dynamic.
Now, patents. That often tells a different story, more about commercial application.
It really does. In 2022, China was way out front in AI patent origins, like 61.1%.
61%. That's massive compared to the U.S.
The U.S. was at 20.9%. And that U.S. share has actually dropped quite a bit since 2010 when it was over 54%.
That's a major shift in just over a decade. The geography of AI innovation seems to be changing.
Definitely. And another huge trend, open source.
On GitHub and places like that.
It's just exploded. Around 1.8 million AI projects on GitHub in 2023.
1.8 million?
And get this, that was a 59.3% jump in just that 1 year.
Wow. So open collaboration is accelerating things dramatically.
It certainly seems that way.
Yeah.
But interestingly, people still value meeting in person.
You mean the big AI conferences?
Exactly. Even with all the online collaboration. Conferences like NeuraPS, ICML, CVPR, AAAI, they still drew huge crowds in 2021. Tens of thousands in some cases.
So there's still a strong pull for that community interaction.
Absolutely. Now, looking at the frontier research, the really cutting-edge model development, there's a clear trend there too.
Industry versus academia.
Yeah. In 2023, industry produced 51 notable new machine learning models. Academia, only 15.
That's a big gap.
It is. But interestingly, collaborations between industry and academia produced 21 models that year, a new high.
So maybe that's the sweet spot, combining resources.
Could be. And related to that, foundation models, those huge versatile models, their releases more than doubled in 2023 compared to 2022. And almost two-thirds, 65.7%, were released with open access.
Open access, so not just giant tech companies keeping them proprietary.
Increasingly, no, which is a big deal for wider access and research.
We hear so much about model size parameters. That's still going up, right?
Oh, yeah. The parameter count has just climbed sharply since the early 2010s. It's a defining trend.
And that means more computing power needed to train them.
Definitely. The training compute for these notable models, especially in the US and China, keeps rising.
Which raises the question, is this sustainable? Are we running out of data or compute?
That's a huge discussion. There were concerns about hitting the limits of internet training data pretty soon.
But maybe not.
The latest reports suggest the current data stock might last longer than people thought. Plus, there's synthetic data.
Right, generating artificial data to train on. Does that work well?
Research suggests layering it on top of real data helps avoid model collapse, which is good. But it doesn't necessarily improve performance beyond just using the real data. It's complex.
One thing that's not complex is the cost. Training these things is getting expensive.
Unbelievably so. Remember the original transformer model back in 2017? Training cost was maybe, what, a few $100s?
Yeah, seems cheap now.
Compare that to GPT-4. The estimated training cost in 2023, around $79 million.
$79 million, that's astronomical.
It shows the scale of investment needed now. But there's a counter-trend. The cost of hardware for a fixed level of performance is actually dropping.
How much?
Estimated around 30% per year. So hardware is getting more efficient, relatively speaking.
And what hardware are they mostly using? Still NVIDIA GPUs.
Seems like it. NVIDIA GPUs are the most common hardware listed for training these big notable models.
Okay. And finally, on the R&D side, the environmental impact, energy use, carbon footprint.
Yeah, it's a growing concern. The reports show estimates for carbon emissions, and they vary wildly depending on the model size, training time, hardware.
So efficiency is becoming a bigger deal there, too.
It has to be. You can't just scale compute indefinitely without thinking about the energy cost.
Right, okay. Lots happening in R&D. Let's shift to technical performance. How good are these systems getting? Image recognition, for example.
Really, really good. On the classic ImageNet benchmark, using extra training data, top 5 accuracy hit over 99% back in 2021.
99%? That's essentially perfect for that task, isn't it?
Pretty much near human level, yeah. And image generation has improved a lot, too. Better FID scores, which measure quality.
What about facial recognition?
Huge progress there, too. Near 100% success on some tough data sets recently. Although face masks did cause a temporary dip. Increased false non-matches.
Huh, yeah. Masks threw a wrench in the works for a bit. And object detection, finding things in images.
Also getting better. On the Kokio dataset, mean average precision reached almost 80% in 2021, again with extra data.
Seems like extra data is a key ingredient across the board.
It definitely helps push performance. Now, language understanding. Benchmarks like SuperGLU and Squad.
They got solved pretty quickly, didn't they?
So quickly that researchers had to make harder versions. Squad 2.0, Reckler for logical reasoning.
And are models still acing those harder ones?
Progress has slowed or plateaued on some, which suggests we need even more challenging benchmarks to really measure progress now.
Interesting. But the practical application, like machine translation, that's booming,
Oh,
right?
yeah, commercial machine translation services. Nearly a five-fold increase since 2017, huge demand.
And these big evaluations like HLM.
Holistic evaluation of language models, yeah. They're showing LLMs are actually surpassing human performance on some standard English benchmarks now.
Okay, surpassing humans on some language tasks. But what about reasoning? That feels like the next frontier.
It is. There's GSM-8K for math reasoning. A GPT-4 variant hit 97% accuracy in 2023.
97% on math problems. That's impressive.
Very. But then you look at something harder, like GPQA graduate-level questions.
How do models do there?
Still a long way to go.
Yeah.
Human experts get around 81% on the hardest part. Models aren't close to that yet. And planning.
Like making a sequence of steps to achieve a goal.
Exactly. Benchmarks like PlanBench show even top models like GPT-4 still struggle quite a bit with that.
So complex reasoning and planning are still major hurdles. What about applying this to the physical world? Robotics.
We're seeing LLMs make robots more flexible. Models like Polym-E, RT2, they let robots understand more complex commands.
So you can talk to the robot more naturally.
Sort of, yeah. The RT2 evaluations showed mixed success better on tests they'd seen, less so on new ones, but the potential is there.
And self-driving cars. Still controversial.
Very. But some emerging research, like Waymo's data, suggests they might eventually be safer than human drivers, based on incident rates. Still early days, though.
It feels like the very top models are getting closer together in performance.
That's what the Chatbot Arena leaderboard suggests. The ELO score difference between the top contenders is narrowing. More competition, more high-quality models available.
And maybe the most interesting part, the gap between the best open models and the best closed proprietary models.
It had nearly disappeared by early 2025, according to the report. That's huge.
It really is democratizing high performance. And it's not just the giants, right? Smaller models are getting good too.
Definitely. Microsoft's Phi 3 Mini Tiny, relatively 3.8 billion parameters, it reached the same score on the MMLU benchmark as Polym, which was massive back in 2022, 540 billion parameters.
Incredible efficiency gains.
Exactly. And we saw other specific advances, Imagen 3 topping image generation benchmarks, Jamba 1.5 mixing architectures for speed and quality.
Cohere's multilingual benchmark, OpenAI's newer models breaking records.
Right, like OpenAI's newer models breaking records.
Right, like OpenAI's O1 and O3 using special techniques for reasoning.
Yeah, things like chain of thought, iterative checking.
Hmm.
Basically, getting the model to think step by step or refine its answers. That seems key for better reasoning.
And the benchmarks themselves keep getting harder.
They have to.
Yeah.
New ones popped up in 2023, MMMU, GPQA, SetWE Bench for coding. And by 2024, models were already showing massive improvements on them.
Like that SWE bench jump, from 4% solve rate to over 70%.
Yeah, dramatic leap in just a year. It just shows how fast things are moving at the cutting edge.
Mind-boggling speed. Okay, let's pivot to responsible AI, or RAI. Beyond bias and truthfulness, what's happening there?
Well, there's definitely more focus on developing and deploying AI responsibly, more concern about assessment and mitigation.
Are people using standard benchmarks for safety and responsibility?
There are mentioned more real toxicity prompts, truthful QA pop up in more papers, but adoption of specific RAI benchmarks still lags way behind the benchmarks used for just measuring capabilities like accuracy.
So we're better at measuring if it works than if it's safe or fair?
Kind of, yeah. And the challenge of factual inaccuracy, hallucinations, it's still very real for LLMs. New benchmarks emerged in 2024 trying to tackle factuality evaluation better.
What about deliberately harmful responses?
The reports track that across different models. It varies, but it's an ongoing issue that developers are trying to mitigate with safety protocols.
But those protocols can be bypassed, right? Adversarial attacks?
Yes. Research keeps finding new, clever ways to trick LLMs into generating harmful content. There are even universal attacks that work on multiple models.
Scary stuff. Are there better ways to defend against these?
Some promising research, like targeted latent adversarial training, or LAT.
LAT, what does it do?
It seems effective at making models less vulnerable to these attacks, and even removing hidden backdoors without knowing the trigger beforehand. Plus, it helps erase harmful or copyrighted knowledge.
That sounds useful. How are actual organizations handling RAI?
Data suggests companies with responsible AI policies see benefits, like faster time to market, better business outcomes.
What risks are they most worried about?
Privacy and data-related risks consistently rank high, looking at 2024 versus 2025 concerns. Those remain top of mind.
Is there a gap between having a policy and actually implementing it?
Seems so. Organizational RAI maturity, like having policies, is advancing, but operational RAI maturity, the technical implementation, is lagging. It's easier to commit than to execute technically.
What about in academia? More focus on RAI there.
Yes, the percentage of RAI papers accepted at major AI conferences is increasing. The reports also show where these papers are coming from geographically.
Okay, 2 more quick RAI points from the report. Data commons shrinking. What's that?
It means more websites are putting up restrictions on using their data for training AI, a big jump from 2023 to 2024.
Why is that a problem?
It impacts data diversity, model alignment, scalability. If you can only train on data you have explicit permission for, the pool shrinks.
Right, and license misattribution.
A huge issue. Data sets often have incorrectly labeled licenses, meaning developers might use data in ways they're not legally allowed to. Big legal and ethical risks there.
Okay, wow. RAI is complex. Let's switch to the economy and education. Jobs first. Where are the AI jobs?
Looking at 2021 data as a percentage of all job postings, Singapore was high at 2.33%. The U.S. was just under 1%, 0.90%. U.K. a bit lower, 0.74%.
And within the U.S., what skills were most in demand?
Machine learning skills had the biggest share in 2021. Clear demand for core ML expertise. The reports break it down by sector and state, too.
What about investment? Money flowing into AI.
Still strong. Global private investment keeps climbing, and generative AI is a huge magnet for funding.
Still, even in 2024.
Yep. Another sharp increase in 2024. It accounted for over a fifth of all AI private investment. Huge focus there.
How are companies actually using AI? Is adoption growing?
Yes, global AI usage by organizations went up in 2024 across all regions.
Yeah.
Greater China and Europe saw big jumps. North America still leads overall, though.
And how are they using generative AI specifically?
Across different functions: knowledge management, coding help, marketing, sales. It's spreading through businesses.
Yeah.
There are also industry predictions about its impact on revenue.
And what do people in businesses think it'll do to the workforce?
Surveys show a mix. Many expect AI to change how they work, and some anticipate significant workforce shifts.
Related to that, robots, industrial robots.
Installations keep rising globally. China has installed more than the rest of the world combined since 2021.
Wow. Are they just in factories?
Increasingly, no. More emphasis on deploying robots in human-facing roles, too.
Yep.
And studies in 2023 suggested AI was making human workers more productive and improving work quality.
So not just replacement, but augmentation, too. What about education? Are we training enough AI people?
Well, AML became the top specialty for U.S. CS PhD grads in 2021 and 5.
Okay, so interest is high at the top level. What about gender balance?
The reports track female PhDs in AI and CS in North America, and trends for master's grads in Europe, APCS exam takers in the U.S.
Are high schools teaching this stuff?
More are. Data shows growth in U.S. high schools offering foundational CS, though it varies a lot by state. And there are still gaps in enrollment demographics compared to the national population.
But universities are stepping up, more AI degrees.
Yes, definitely seeing more U.S. institutions offering specific AI bachelor's and master's degrees. The pipeline is growing.
Okay, education is adapting. How about governments? Policy and governance.
Things are accelerating there. Lots more discussion globally about AI governance and regulation.
In the U.S. specifically.
More mentions of AI in Congress, and a big jump in state-level AI laws being passed. Governments worldwide are also investing more in AI infrastructure.
Are the regulations becoming more targeted?
Yeah, the reports categorize U.S. regulations, and a growing share are seen as highly relevant, specifically targeting AI issues.
And public funding. Is government R&D spending on AI going up?
In the U.S., yes. Budgets for non-defense AI, R&D, and DoD AI requests have increased. Government contract spending on AI is also significant, especially for machine learning and computer vision in 2023.
And this is happening elsewhere, too.
Yes, the reports show public spending on AI contracts in other key countries as well. It's a global trend.
Okay, nearly there. Science and medicine. Any big AI milestones recently?
2024 saw some cool stuff. LLMs being used to optimize protein sequences, AlphaProteo generating successful protein binders.
Like designing new drugs or biological components.
Exactly. There's also a virtual AI lab speeding up biomedical research. It helped design nanobodies for SARS-CoV-2.
Wow. Are medical LLMs getting good?
Their clinical knowledge is improving based on benchmark evaluations.
Yeah.
But they still struggle with hallucinations and performing well across different languages.
Are regulators like the FDA approving more AI medical tools?
Yes, a steady increase in FDA approvals for AI-related medical devices. And some models are showing seriously impressive medical knowledge.
Like which ones?
GPT-4 MedPrompt hit over 90% accuracy on the MedQA benchmark. That's highly knowledgeable.
Impressive. Okay, last big section. Public opinion. How does the world feel about AI?
Globally, people seem cautiously optimistic. A 2024 survey across 26 nations found 55% think AI products offer more benefits than drawbacks. That's up slightly from 52% in 2022.
Is that optimism everywhere?
Interestingly, the biggest jumps in optimism were in countries that used to be the most skeptical. So some minds are changing.
What about specific things like self-driving cars? Still distrust there.
In the U.S., yes, distrust remains high, though the percentage fearing them dipped slightly from its 2023 peak.
Do people want AI regulated?
Broad support for regulation, especially among local U.S. policymakers, a big jump in support there between 2022 and 2023.
How do people think AI will affect their jobs?
Globally, 60% think it'll change how they work, and about 36% worry it might actually replace their job within 5 years.
So a mix of adaptation, expectation, and replacement fear. Is everyone aware of things like ChatGPT?
Awareness is pretty high. 63% in one international survey knew of ChatGPT, and about half of those aware use it at least weekly.
What are the biggest concerns people have about AI globally?
Top concerns include accuracy of results, ethical implications, the impact on jobs, and privacy violations. Pretty fundamental worries.
Do people trust companies using AI?
It varies a lot by country. Trust levels are quite different depending on where you look.
And how much do people feel AI has already changed their daily lives?
Again, varies by country. Some feel it's already had a profound impact, others less so.
One last bit. Economy versus jobs. How do people feel AI will impact those?
Globally, more people expect AI to boost the economy than think it will enhance the job market.
Interesting distinction. Optimism about overall growth, but less about individual job prospects.
Seems that way, yeah.
Okay. Well, that really covers a huge amount of ground from these AI index reports. We've touched on the incredible pace of R&D, the performance breakthroughs.
The persistent ethical challenges, the shifting economic landscape, governments trying to catch up, and how the public is feeling about it all.
Yes, some surprising things too, like the smaller models punching above their weight, the open versus closed model gap closing. Hopefully this deep dive has given everyone listening a clearer picture without getting totally swamped.
Absolutely. It's a complex field moving incredibly fast.
So maybe a final thought to leave people with. Given everything we've discussed, the speed, the interconnectedness, what single aspect of AI's future do you think might have the biggest impact on our lives?
That's a tough one. Maybe the increasing integration into everyday tools and decisions almost invisibly. What questions does that raise for you?
That's definitely something to chew on. What does it mean when AI is everywhere, even when we don't realize it? Lots to think about. Thanks for joining us for this deep dive.